Our universe is a vast and mysterious place. It's filled with billions of galaxies, each containing billions of stars. But have you ever wondered how it all began? The answer, many scientists believe, lies in an event called the Big Bang. Imagine a time about 13.8 billion years ago. Our universe, as we know it, was compressed into a tiny point, smaller than an atom. This point, called the Singularity, was incredibly hot and dense. It contained all the matter and energy that would eventually make up everything we see around us today. Then, something extraordinary happened. The Singularity began to expand. This expansion continues to this day, pushing galaxies farther and farther apart. At the heart of the Big Bang Theory lies the concept of the singularity. Picture a point so incredibly small that it's almost impossible to comprehend. This point, the singularity, held within it the potential for everything we see in the universe today. Imagine all the matter and energy in the entire cosmos, squeezed into a space smaller than an atom. That's the singularity. It was a place of unimaginable density and temperature. The laws of physics as we know them break down at such extremes. The singularity wasn't just a collection of stuff, though. It was a point of pure potential. It contained the seeds of galaxies, stars, planets, and even life itself. Then, in an instant, the expansion began. One of the most common misconceptions about the Big Bang is that it was an explosion. People often picture a giant fireball erupting into a vast, empty space. However, the Big Bang was something far more subtle and profound, an expansion of space itself. Imagine a balloon with dots drawn on its surface. Each dot represents a galaxy. Now, as you inflate the balloon, the dots move farther apart. The balloon's surface, like space itself, expands, carrying the dots along with it. Similarly, the Big Bang wasn't an explosion of matter into space, but rather the expansion of space itself. This expansion continues to this day, and we can observe it through a phenomenon called redshift. In the first fleeting moments after the Big Bang, the universe was an incredibly hot and dense soup of elementary particles. Quarks, electrons, and other fundamental building blocks of matter zoomed around at incredible speeds. As the universe expanded, it cooled. This cooling allowed the particles to slow down and interact with each other. Protons and neutrons, the building blocks of atomic nuclei, began to form. Around 380,000 years after the Big Bang, the universe had cooled enough for electrons to become bound to these nuclei, forming the first atoms. This event, known as recombination, marked a pivotal moment in the universe's history. After recombination, with the electrons bound into atoms, the universe became transparent. Section 5. Lighting up the cosmos. The birth of stars and galaxies. After the formation of the first atoms, the universe entered a period known as the Dark Ages. It was dark because there were no stars yet, just vast clouds of hydrogen and helium gas. Gravity, however, was at work. Over millions of years, gravity pulled these clouds of gas together. As the clouds collapsed, they became denser and hotter. Eventually, the temperatures and pressures at their cores became so intense that nuclear fusion began. This fusion of hydrogen into helium released tremendous amounts of energy, and the first stars ignited, bathing the universe in light. These early stars were massive and short-lived, ending their lives in spectacular supernova explosions. Section 6. Echoes of the Big Bang. The cosmic microwave background. The Big Bang Theory isn't just a compelling story. It's supported by a wealth of scientific evidence. One of the most compelling pieces of evidence is the cosmic microwave background radiation, often called the CMB. Imagine looking back in time to an era just 380,000 years after the Big Bang, the time of recombination when the first atoms formed. As we look back across this vast gulf of time and space, we are essentially seeing the afterglow of the Big Bang itself. This afterglow, the CMB, is a faint microwave radiation that permeates all of space. The CMB is incredibly uniform, with a temperature of just 2.7 Kelvin or minus 455 degrees Fahrenheit. Section 7. A Universe on the Move, Hubble's Expanding Discovery. In the 1920s, astronomer Edwin Hubble made a groundbreaking discovery that revolutionized our understanding of the universe. By observing distant galaxies, he found that they were moving away from us. Moreover, the farther away a galaxy was, the faster it was receding. Hubble's observations led to a profound realization: the universe is expanding. This expansion, as we've seen, is a key prediction of the Big Bang theory. Hubble's discovery provided the first observational evidence to support the idea that the universe had a beginning. The expansion of the universe is often compared to the dots on an inflating balloon. As the balloon expands, the dots move farther apart. Section 8. The Fate of the Cosmos. A look into the distant future. The universe is expanding, but what does the future hold for our cosmos? Will it continue to expand forever, or will it eventually collapse back in on itself? Cosmologists have proposed several possible scenarios for the universe's ultimate fate. One possibility is the Big Freeze. In this scenario, the universe continues to expand and cool indefinitely. Eventually, stars will cease to form, and the universe will become a cold, dark, and empty place. Another possibility is the Big Crunch. In this scenario, the expansion of the universe eventually slows down and reverses. Gravity pulls everything back together, and the universe collapses in on itself. Section 9. Our Place in the Grand Scheme. The Big Bang Theory paints an awe-inspiring picture of our universe's origin and evolution. It tells a story of cosmic expansion, the formation of stars and galaxies, and the emergence of the very elements that make up our bodies. As we contemplate the vastness of the cosmos and the incredible journey of the universe from a tiny singularity to the complex structures we see today, it's humbling to consider our place in this grand scheme. We are, in a very real sense, children of the Big Bang. The atoms in our bodies were forged in the cores of stars that lived and died long ago. We are connected to the cosmos on a fundamental level.